So here solutions, suspensions, and another one is colloidal solutions. Colloidal solutions. Okay, solutions, suspensions, and colloidal solutions. 1, 2, and 3 types are there. Okay, so before going to this, we can know about the Tyndall effect. Okay, so that is Tyndall effect. So what does mean by Tyndall effect? Okay, so that is if it is a light. Okay, if a light is passed through a medium. Okay, if a light is passed through a medium and its path can be seen, so we can observe clearly the path of a light that is getting inside a dark room. Okay, so you are sitting inside the dark room. The light, the sunlight, or any torchlight or any other light, okay, the light medium, it comes into the dark room by a small hole. Okay, so by a small hole, okay, you can observe like this. It is a window. Okay, here you have a small hole. Okay, so the light is entering inside this small hole. Okay, it comes like this. Isn't it? You can observe like this. Okay, in a dark place. Okay, or you can observe a shadow in a light. Okay, at a night time. So that also we can say it is a Tyndall effect. Okay, that is its path can be seen. Then the substance is said to show Tyndall effect. Okay, you can observe that is a tall trees in a forest. Okay, in a forest we have a tall trees. Under the tall trees we have observed a dark in that. Okay, dark inside the tall trees in the forest. Okay, so there is a sunlight or entering into that forest. Okay, there is a Tyndall effect. We can observe that light medium inside the dark objects. Okay, that we can say it is a Tyndall effect. Okay, so that is a light medium. Okay, a medium light enters into the dark place by a small holes. Okay, by a small holes that we can see, observe. So if it is a very dark sunlight, we are moving inside the home. Okay, we can observe all the things are very dark. Okay, and in that place we are observing the sun rays inside our home. Okay, at that sun rays we are observing the small particles, small dust particles in the sunlight. Okay, so that we are observing the sunlight, that we can say is a Tyndall effect. Okay, so now you know what does mean by Tyndall effect. If a light medium, okay, if a light is passed through a medium, here what is a medium? Here air is a medium. Here is a medium. In this we have the light is enters by a small hole, so it observes it. We can see by our naked eyes. We can see that light. Okay, light rays. That we can say it is a Tyndall effect in a medium. Okay, Tyndall effect. When a beam of light enters in a dark room, okay, by a small hole, that we can say it is a Tyndall effect. Okay, so then we move on to the types of mixtures. That is first one, solutions. Okay, first one is solution. So a solution is defined as a homogeneous mixture. A solution is also a homogeneous mixture. I told already the example: salt with water and sugar with water. So a solution is defined as a homogeneous mixture of two or more chemically non-reacting substances. Whose composition can be varied within limits. Okay, that is a solution as having two components. Okay, so what is meant by a solution? A solution is also having a homogeneous solution. Also saying it is a homogeneous mixture. Okay, and it is mixed with the two or more chemically combined. Okay, chemically non-reacting substances. And it is having a limits within it. Okay, while mixing, it has a limits within it. Okay, so it varies by the limits. So we have two components in a solution. Okay, so there is a two components in a solution. What are that two components? That is solute and solvent. Solute and solvent. What are the two types of components in a solution? Solute and solvent. Solute and solvent. So what is mean by solute? The component which is dissolved in the another component. Okay. Another component, which is another component? Solvent. Okay. So the solute is dissolved, fully dissolves in the another component, that is solvent. Okay. A solute is a component, okay, which is dissolved in the solvent, which we can say it as a solute, and solute is a particle which is having a less amount comparing to the solvent. Okay, comparing to the solvent, we are taking solute is a less amount in the solution. Okay, that is a mixture. In a mixture, solute particles we can take it as a less amount. Okay, that we can say it is a solute, and we are taking a large amount in a solution, that we can say it is a solvent. Okay, and it having a capacity to dissolve the solute particles in it. It is having a capacity to dissolve the solute particles in it. This we can say it is a solvent. Okay, understood, children? Okay, then we can see types of solutions. What are the types of solutions? We can dissolve the types of solutions. No? Solid in solid, and solid in gas, solid in liquid, liquid in solid, and liquid in so any other particles. That is liquid in solid, gas in solid. Okay, so solid in solid again. So we have 9 types of particles. That is 9 types of solutions. Okay, solid in solid, solid in liquid, solid in gas, liquid in solid, liquid in liquid, liquid in gas. So gas in solid, gas in liquid in solid. Okay, so gas in gas, and liquid in gas, solid in gas. So like this, 9 types of solutions are available there. Okay, by the solutions, by solute and solvent. Okay, and what are the properties of solutions? What are the properties of solutions? So a solution is a homogeneous mixture. You know that a solution is also homogeneous mixture. Okay, size of particles is smaller than the 1 nanometer. Size of particles in a solution. Size of particles in a solutions are very small. Okay, so how it is small means we can say it is a less than 1 nanometer. Okay, smaller than 1 nanometer. 1 nm. Nm means nanometer. This we can say it is a 10 to the power of minus 9 meter. 10 to the power of minus 9 meter. 10 to the power of minus 9 meter. Okay, understood? So this we can say size of particles are very smaller than the particles, smaller than the 1 nanometer. So 1 nanometer we can say it is a 10 to the power of minus 9 meter. Okay, so the particles cannot be seen by microscope also. Okay, so we can't see by our naked eyes, but also we can't see the particles inside the solutions by a microscope also. Okay, so that is very too small. Okay, so we can't see by the microscope also. Okay, so it is a stable mixture. Solute does not settle down over a period of time. Okay, so we are mixing a salt with water and sugar with water. There is no particles which is settled down under the solution. Okay, so this is the properties of solutions. And if solution is passed through filter paper, solute and solvent do not separate. Okay, so we can't separate the solute and solvent in a solution by the filtration method. Okay, and this solution doesn't apply the Tyndall effect. Okay, so it does not scatter light. It do not show Tyndall effect. While the light is entering by the small hole into the another medium, there is a scattering of light. There is a scattering of light. That is dividing of light. Okay, that is scattering of light. Okay, it moves in all the directions. Okay, so here there is no scatters of light in the solution. So it doesn't show the Tyndall effect. It doesn't show the Tyndall effect. Okay, understood, children? So what is the solutions and what are the types of solutions? Okay, and then we move on to the suspensions. Okay, so what does mean by a suspension? A suspension is a heterogeneous mixture. So this is is a homogeneous mixture. This is a homogeneous mixture and this is a heterogeneous mixture. Heterogeneous mixture. So suspension is a heterogeneous mixture. Okay. So and then in which the solid particles do not dissolve but remain suspended throughout the bulk of medium. Okay. So here suspension. In a suspension, here also there is a two types of atoms or molecules mixing. Okay. So here in which the solid particles do not dissolve but remain. Okay. So here the solid particles do not fully dissolve in the solvent. Okay. Here the solid particles do not mix fully with the solution solvent and it remains suspended throughout the bulk of medium. It's suspended throughout the medium. Okay. So we can see our naked eyes. Okay. We can see our naked eyes the solid particles in the suspension. Okay. That we can say it is a suspension. So what are the properties of suspension? What is the first property? It is a heterogeneous mixture. It is a heterogeneous mixture. Okay. And size of particles is greater than the 100 nanometer. Okay. Size of particles. So the solid particles are very small. So it is less than the 1 nanometer. But here the size of particles we can say it is a 100 nanometer. 100 nanometer. The size of particles in a suspension is 100 nanometer. Okay. And particles can be seen by our naked eyes. Okay. And it is unstable mixture. Solute settles shown the under of the particle, the bottom over a period of time. It settles down under the bottom over the period of time. Okay. So then if the solution is passed through filter paper, solute and solvent gets separated. If we are doing the filtration method, the solute and solvent particles are separated by the filtration method. It scatters light when light is passed through the solution. It shows Tyndall effect. The suspension particles can show the Tyndall effect and it scatters light inside it. For example, we can say that is sand with water. Okay, in a sand with water, the solid particles partially mixed with the water and the undissolved particles are stayed under the bottom of the solution. It takes a period of time. Okay, and it scatters light inside the medium. Okay, and it shows the Tyndall effect. Okay, understood, children? Okay, then move on to the colloidal solution. What is mean by colloids? So a colloids is also a heterogeneous mixture. Solutions in which the size of particles lies in between those of true solutions and suspensions are called colloidal solutions or simply colloids. Okay, so that is in a solutions. Okay, in a solutions, that is here we have a true solutions and some particles which is having a properties of suspension. So both these combination we can say it is a colloidal solutions. That is we can say it is a colloids. Okay, so here see there is solutions. Some are showing the true solutions. Okay, and some of that shows the particles of suspensions. There is properties of suspensions. So both this combined we can get the colloids. That we can say it is a colloidal solutions. Okay, so the properties of colloids. Colloids is also a type of heterogeneous mixture. Colloids is also a type of heterogeneous mixtures. Okay, so that is here we can say the size of the colloids. The size of the particles of the colloids are smaller than the suspensions. Okay, that is but greater than the solutions. See here we have the combination of solutions and suspensions. We can say it is a colloidal solutions. So here the particles in the colloidal solutions are that is greater than, okay, that is greater than suspension. Okay, greater than suspension and less than solutions. Okay, so that is it is greater than 100, sorry, it is less than suspension and greater than solutions. Okay, so greater than solutions less than suspension and greater than solutions. Okay, less than suspensions and greater than solutions. So 100 nanometer is a suspension and 10 to the power of minus 9 meter. Okay, that is 1 nanometer is a solution. Is it right? 1 nanometer is a solution. So here collides is having the size. Okay, the size of the collides are that is smaller than the suspensions and greater than the collides. Okay, that is greater than the solutions and less than the suspensions. Okay, so colloid particles, which is having the size of the colloid particles in the colloidal solution, is greater than the solutions and less than the suspensions. Okay, that is less than 100 nanometer and greater than 1 nanometer. Okay, greater than 1 nanometer and less than 100 nanometer. In between that, the particles of the colloidal solutions are inside these two measurements. Okay, understood children? Okay, then particles can be seen by the microscope, but the particles of the solutions we can't see by the microscope, but here the particles of the colloidal solutions we can see by the microscope. Okay, and then we have, that is where the solution passes through the filter paper. Okay, the solute and solvent do not separate of the colloidal solutions, but the suspensions we can separate by the filtration method. But here the colloidal solutions doesn't separate the solute particles and solvent particles by the filtration method. Okay, so here also there is no observation of Tyndall effect. Okay, so inside this colloidal solutions also there is no scattering of beam of light. Okay, so it does not shows the Tyndall effect. Okay, understood children? These are the properties of the colloidal solutions. First one, it is a heterogeneous mixture and solutions are homogeneous mixture. These two are heterogeneous mixture. So what is meant by colloidal solutions? That is both combination of solutions and suspension particles. We can observe that we can say it is a colloidal solutions. Okay, and the size of the solutions are smaller than the 1 nanometer, that we can say 10 to the power of minus 9 meter, and the size of suspension particles are 100 nanometer. Okay, and size of colloidal solutions are in between these two, that is which is greater than 1 nanometer and which is less than 100 nanometer. Okay, and solution particles doesn't see by the naked eyes, and suspension we can see with our naked eyes, and colloidal solutions also we can see with our naked eyes. But in filtration process, only the suspension particles we can separate the solute and solvent particles by the filtration method. But solutions and colloidal solution does not separate the solute and solvent particles